Hi, in this video I'm going to explain how to use slope-intercept form for linear equations. For today there are three important questions. First, in an equation in the form y equals mx plus b, what do m and b represent? Second, if you have an equation in the form y equals mx plus b, how can you graph that equation as a line? And third, if you have a graph of a line, how can you write the linear equation that represents that line? First, we'll look at three different equations. Each one is a little bit different from the others, and we're going to see how those changes affect the graph. So first we've got y equals x, then we'll look at y equals x plus 1 and y equals x plus 2. Notice that in the first equation, there's no constant being added to x, and in the second and third, we do have constants, plus 1 and plus 2. So we'll see how that changes the graph. So first we'll pick some x values to try, x equals 0, 1, and 2, and then we'll put those in and find y. First we have y equals x, so whatever x is, y will be the same. If x is 0, y is 0, if x is 1, y is 1, and if x is 2, y is 2. Next, we'll look at y equals x plus 1. So again, we'll use x equals 0, 1, and 2, and then we'll find y. So y will equal 0 plus 1, which is 1. Then we'll have y equals 1 plus 1, which is 2, and y equals 2 plus 1, which is 3. So we've got our three y values. And finally, we'll look at y equals x plus 2. So again, we'll use x equals 0, 1, and 2, and then we'll find our y values 2, 3, and 4. From this table that we've created, we can pull out the points that are ready to graph. So for the first black function, we're going to have 0, 0, 1, 1, and 2, 2 as our points. For the blue function, we'll have 0, 1, 1, 2, and 2, 3. And for the pink function, we'll have 0, 2, 1, 3, and 2, 4. So now we can go ahead and graph those points. And remember, we're looking to see how these changes in the equation affect changes in the graph. So you'll notice when we graph these three lines, they're all parallel. Each line is parallel with the others. They have no points of intersection. But it looks like as the functions change, the graphs sort of jump up the coordinate plane a little bit. And if you look at the y-axis, you can see that where each function intersects the y-axis is dependent on the number that's being added, the constant in the function. So that black function is y equals x, or y equals x plus 0, and it intersects the y-axis at y equals 0. Similarly, the blue function, y equals x plus 1, intersects the y-axis at y equals 1, and the pink function intersects at 2. So that number, that constant that's being added in the function, lets us know where on the y-axis the line will cross, and that's called the y-intercept. So now we're going to look at three more examples. This time there won't be any constant term added, but there will be a coefficient multiplying the x term. So we'll look at y equals x again, y equals 2x, and y equals 5x. So we'll make a table again in the same way, and y equals x, of course, will have the same values it did before. And then for y equals 2x, for our x values 0, 1, and 2, we'll have y values 0, 2, and 4. And then for the last function, for our x values 0, 1, and 2, we'll have y values 0, 5, and 10. So now we can graph these three lines, and we can see that they look very different than the examples we looked at before. They're not parallel. Each one has a different level of steepness. And you can see that all of these three lines cross the y-axis at the same point, at y equals 0. And that's because each of these equations has no constant term being added. The constant term is plus 0, which is just like our first example from before. But the difference here, of course, is the x, 2x, and 5x. So whereas before we had parallel lines, now we've got 3 lines with different levels of steepness, some going up very sharply and some a little bit more shallowly. And the term for that is called slope. It's the measure of how steep or shallow a line is. And that, of course, can be rising or falling. So y equals x, which we can also write as y equals 1x, has a certain level of steepness, and then 2x is steeper than that, and 5x is steeper than that. So it seems like as that number that's multiplying x gets larger, the steepness increases, and as it gets smaller, the graph gets shallower. So when we have this general form of the equation, y equals mx plus b, which is called slope-intercept form, we've got these two values that tell us some information about the graph, m and b. M is the slope, and b is the y-intercept, and they let us know what the graph will look like. If we have numerical values for m and b, then we're ready to graph the line. One way to conceptualize slope and y-intercept is to think of b, the y-intercept, like an address. It's an actual location. It's a specific place where you can go to and start your graph there. M, on the other hand, is like directions that tell you how to walk from B to another point. So M itself is not a place we can go to. It's rather directions that tell us how to move on the line. But B is a real place we can go to. So for example, suppose we had y equals 5x plus 2. So 2 is the address, or the starting point we go to. It's the y-intercept. So we can put a point on the y-axis at 2. And then 5, we're going to want to write that as a fraction, 5 in the numerator and a 1 in the denominator. Because you might remember from learning about slope in my previous video, slope tells us how to move up and down and how to move left and right. So the numerator 5 will tell us how to move up and down, and the denominator 1 will tell us how to move left and right. So we're going to go back to that starting point of 2, and the numerator is a positive 5, so we'll go up 5. And the denominator is a positive 1, so we'll go right 1. And those are the directions that tell us how to walk to another point on the line. And once we have those 2 points, we can connect them with a line that represents all the points that satisfy this equation. So the takeaway here is that 2, or b in the general equation, is our starting point. And m, remember, is not a place we can go to. It's a way to move between points. So in this next example, you can see we don't have an equation written, but we have the slope and the y-intercept that have been given to us. The slope is negative 4 over 5, and the y-intercept is 7. So again, the 7, the y-intercept, is going to be our starting point, or address, where we go first and make a point at y equals 7. And then the slope is what's going to tell us how to walk from that point to another point on the line. So we can start with negative 4, which tells us to move down 4 along the y-axis. And then positive 5 tells us to move right 5 steps and put a point down there. So now suppose we have a graph, a line already on the graph, and we want to know what's the equation that matches that graph. So that means we need to find m and b, the slope and y-intercept, from this graph. So remember that b means where the line intersects the y-axis. So we can just look along the y-axis and see where our blue line crosses it. And we can see that happens at negative 3. So that's our b, negative 3. So we can make note of that and just hold on to that for a second. And then m is how we move from one of these points to the other. So if we start at this starting point of negative 3, we can see we go up 4 steps. So we'll hold on to that information for a second, and then we'll go left 3 steps. So that's a negative 3. So that makes our slope 4 over negative 3. And we can write this equation as negative 4 over 3x minus 3. Now suppose we started at that top point instead and moved to that y-intercept point. So again, our first move would be vertical. So we'd go down 4, which is -4, and then we'd move right 3, +3. So the important thing to note here is that 4 over -3 and -4 over 3 are equivalent. Those are the same thing. So our slope is -4/3. And we can write the equation as y equals -4/3 x minus 3. That equation means the same thing as this graph. So if we were to pick any x value that we liked and put it into this equation, we could use that to solve for y, and that pair, x and y, would appear on this blue line. So now to wrap up, let's go back to those 3 questions from the beginning. First, in the equation y equals mx plus b, what do m and b mean? Second, if we have an equation like that, y equals mx plus b, with numbers in place of m and b, how do we graph the line from that equation? And finally, if we have a graph of a line, how do we write the equation that represents that line? I hope that after watching this video, you feel a little bit more comfortable with those questions and have a sense of how to answer them. If not, please let me know and I'd be happy to go into more detail. That's it. Thank you so much for watching and have a great day.